Okay, so in this example, they want us to find the exponential function. In the last example, they gave us the function and we were just, using it. But now we have to find it ourselves. Okay, so in 2006, 80 deer were introduced into a wildlife refuge. By 2012, the population had grown to 180 deer. Okay, so we know in 2006, 80 deer, and then it grew to 2012, 180 deer. Okay, the population was growing exponentially. Write an algebraic function n of t, so they tell us what to call it, representing the population n of deer over time t. Okay, so what are we looking for? We're looking for an exponential function. The general form says this. Okay, that's the general form. A is going to represent the initial number. Now, you can figure that out algebraically too, so we can go ahead and do that. But we're starting in 2006. We're going to say that is 0 years then, okay? So when we're basing this on time, so if n of t is equal to a b to the t, and we're saying, okay, n of 0 is going to equal a b to the 0, and that's going to equal 80 deer, then that means a is 80. So you could write it out algebraically. Okay, so we know what a is. Now we have to figure out what b is. So we're going to go to the other piece of information. Let me see if I've answered maybe what questions that you might be thinking of. Why is 2006 0? That's the only information we have to begin with. So that's our starting timeline. We're going from 2006 to 2012. And that's all the information we have. So we set 2006 as our 0, our initial number of deer, and then we're going to do 2012 here in a second. Okay. So in 2012, how many years have gone by? T is going to be 6, right? So we'll have n of 6 is going to equal a, which we know, 80, b to the 6. Try to make my b and 6 look different. And we know how many deer there are, okay? So now we're saying this is 2012, 6 years later, so our function looks like n of 6. We know it's going to equal 80b to the power of 6. What we don't know is b, and that's what we're trying to figure out. Then we can write the model based on our general model of an exponential function. Okay, but we know there's 180 deer after 6 years. So we get 180 equals 80 b to the 6th power. Okay, so divide both sides by 80. And I'm going to get that reduced to 9 over 4. Now, you've got to be careful with these fractions and your notations with the rounding and stuff. We do not want to round at this point, okay? So I'm going to talk a little bit more about rounding at the end here. But reducing that fraction, you do get 9 over 4, and that's okay. That equals b to the power of 6. Well, we're trying to solve for b, so how do you get rid of that exponent? You might be thinking take the 6th root, which is fine, but you can also raise it to the power of 1/6. So it's probably going to be easier to use this fraction notation when it comes to actually putting it in the calculator. Okay, so that gives us then on the right-hand side just b, and then we're going to have to figure out what 9 divided by 4 to the 1/6 power is, okay? And now it's a calculator thing. So in our calculator, we're going to put parenthesis 9 divided by 4. You could figure out that decimal because 4 is going to go into 9 evenly. It's not going to be a repeating decimal. But what if it had been a 3? You're going to get this repeating decimal, and we don't want to round off in intermediate calculations. We only want to round at the end because it'll make a huge difference in your answer. So I just want to point that out to be careful on that. So I'm going to write 9 divided by 4. I'm going to raise it to the power. And then here's a mistake that students sometimes make. You have to put that exponent in parentheses. If you don't, you're not going to get the right answer, okay? So we were raising it to the 1 divided by 6, okay? And again, we don't want a decimal there because it's going to be a repeating decimal, and we want the whole thing. We want it to be precise, okay? So I'm going to stop so you can do that on your calculator. Whew. So on my calculator, I get like 1.144714243. That's what it says. Now, they tell us to round B to 4 decimal places. They don't really say that in the directions, but later on they talk about that. So 4 decimal places is going to mean this is approximately, this is B, and it's approximately 1.1447. Okay, so that's what it would be rounded off. In the book, they say we're from this point on, unless it tells you otherwise, we're going to round to 4 decimal places. Okay, so we'll see how that goes, but anyway, we'll just assume that if they don't say round to 2 decimal places or something else, we're going to round to 4 decimal places. Okay, so now we found B. We know A. A was 80, so you might remember that from what we did previously. Now we need to write the actual function. So I'll rewrite the model that we have, A, B to the x, but our model is going to look like this. N of t, where n represents the n of t represents the population of deer, and it's going to equal 80. The b is 1.1447 to the power of t. So that would be our function.